Okay, this is going to cover section 6.1. It's an introduction to factoring. Factors are two numbers that are two or more numbers multiplied together, and they give us a product. So product is the answer to that multiplication problem. For example, that's not what I meant to do. In this problem, or these problems, the factors are in red and the products are in blue. So the factors are the things multiplied, the product is the answer. To find common factors, we just list factors of each and find things that are the same. So for this 8x, 8 is like saying 2 times 4, and x is like saying x times x. So factors could be 2x times 4x. 6 is like saying 2 times 3, and we only have 1x. So we could say 6x is 2x times 3x. And then a common factor between the two would be 2x, because they both have that as a factor. You can simplify polynomials, so those are multi-term expressions, by factoring out or dividing the common factors. So we just said 8x squared and 6x are both divisible by 2x. They have that in common. So let's divide. 8 divided by 2 is 4, and x squared divided by x is x. 6 divided by 2 is 3, and x divided by x is 1. So these two expressions are equal. 8x squared plus 6x equals 2x times, in parentheses, 4x plus 3. The greatest common factor is, if you list all of the common factors, the biggest one that's the same. So it's the largest factor that is in both. One way to find that is to break it down or do the prime factorization, meaning you find all the prime factors, and then figure out what's common, multiply the common ones. Multiply common ones. So I'll show you what I mean by that. So 12, one way we could say that is 3 times 4. 3 is a prime number, so we stop there. 4 is not. 4 is 2 times 2. Those are prime numbers. And then x to the 4th means I have 4 x's. 1, 2, 3, 4. And we can't break those down any further. 9 is 3 times 3. Those are both prime. We have 1x and we have 3y's. So those are the factors broken down as far as we can get. Now we're going to find what's in common. So both of these have a 3. Both of these have an x. That's what's common. So we multiply those together. 3 times x is 3x. That's our greatest common factor. Now, if we were going to factor it out like we did up here, we take what's left and multiply that together. So 2 times 2 is 4, and then we have 3 x's. So that would be 4x to the 3rd. This one, we have a 3. Well, that's not very different. We have a 3, and then we have 3y's. So we'd be left with 3y cubed. So the red is our greatest common factor. The blue and the purple is what's left. So if we had this, we have 12x to the 4th plus 9xy cubed, which are these two original ones. The greatest common factor is 3x. 12x divided by 3x is going to be 4x cubed. We already did that multiplication and division. And then 9x cubed divided by 3x is 3y cubed. Now we have factored out, which just means divided out the greatest common factor. And this is what we're left with. Here's a bunch to do. I'm going to do a couple where I do the prime factorization. I'm also going to do some where I show you if you recognize the factor, you don't have to do the prime factorization all the way out. It's an option. So let's look at this first one. 10x and 6. Well, 10 is 2 times 5. Those are both prime. And then we have an x. 6 is 2 times 3. What's common is the 2. So I would take out 2. In this one, I'd be left with 5x. In this one, I'd be left with 3. And we had a plus sign in between. It's one way to do it. Another way is to, let's look at that top middle one. Maybe I just look at it and I say, hey, I know 6 and 15 are both divisible by 3. I also know both of those terms have an x. So now I'm just going to divide that out. 6 divided by 3 is 2. If I have x squared and I take out an x, there's 1 left. 15 divided by 3 is 5. And if I have an x and take it out, there's no x left. I would get the same answer whether I did the prime factorization like I did on number 1 or just divided it out in my head like number 2. That's up to you. So I'm going to do 2 of these as prime factorization, 2 of these like I did number 2. You can do them either way you want, then go back and check. So let's see, prime factorization. If I did this one, I'd have a 3 and a 5 and 2 x's. This one, I'd have a 2 and a 5 and an x. So what's the same is a 5 and an x, 5 and an x. So if I take out 5x, I'm left with 3x plus 2. If I did number 4 down here, they're both divisible by 2y squared. 6 divided by 2 is 3. If I have 3y's and I take out 2, there's 1. And then 2 divided by 2 is 1. Y squared divided by y squared is 1. So that's what I'm left with. This one, they're all divisible by 3 and they all have a z. 3 divided by 3 is 1. Z cubed, take 1 out, I have 2 left. 9 divided by 3 is 3. Z squared, take 1 out, I have 1 left. 6 divided by 3 is 2. If I did prime factorization on this last one, so 2 is already a prime number. Then we have 2 x's and we have 2 y's. Here, 4 is 2 times 2. We have 1 x and we have 3 y's. The common parts are 2, an x, and 2 y's. So if I take out 2x and 2 y's, I'm left with x in the blue one and 2y in the green one. So there are 6 different ones that we took out the greatest common factor. Now, if you have 4 terms, one way to factor these into 2 binomials is called factor by grouping. So we're trying to turn this polynomial of 4 terms into 2 binomials that if we FOILed them out, we would get that same polynomial of 4 terms. So the first step is to look for a greatest common factor. All of these terms are divisible by 2, so I'm going to start by taking that out. 2x cubed divided by 2 is x cubed. 2x squared divided by 2 would give us x squared. 4x divided by 2 would give us 2x. And 4 divided by 2 would give us 2. Next step, order the degrees from greatest to least. So those are our exponents. We want to make sure our exponents go from greatest to least. So 3, 2, 1, 0, these are all set. Then we make sure the middle sign is positive. This middle operation, we want to make sure it's positive. I'll show you in a minute what to do if it's not. Now we're going to group it into 2 binomials. So we're going to put parentheses or brackets around the first 2 terms and the second 2 terms. Now we take the greatest common factor out of each of those pairs. So in this first pair, I can take out x squared, and I would be left with x plus 1. And in the second pair, I can take out 2, and I'm left with x plus 1, because 2x divided by 2 is x. 2 divided by 2 is 1. Now, we're going to rewrite as two binomials. So the first binomial are the terms I pulled out, the x squared and the 2. Then notice these are the same. So that's going to become our second binomial. Bring down our greatest factor. And now we have factored that out. If I were to multiply this out, I would end up with the original polynomial. That's a way to check it if you want, but those are the steps. I'm gonna do a couple more. Whenever you feel comfortable that you've seen all the steps, go ahead and pause the video and try them. But I'm going to go through all of them. You decide when you're ready. All right, check for greatest common factor. 2, 4, 3, 6. There is no greatest common factor, so we're done with step 1. Step 2, degree greatest to least. 3, 2, 1, 0. We're all set there. Middle sign is already positive. So we can go straight to step 4 where we have two binomials. Take out the greatest common factor. So 2x cubed and 4x squared. I can take out 2x squared. 2 divided by 2 is 1. X cubed divided by x squared is x. Negative 4 divided by 2 is negative 2. And x squared divided by x squared is 1. Now we do the second one. I can take out 3. And I'm left with x minus 2. So now I rewrite. I take the ones I pulled out. 2x squared plus 3. Then I take the one that matches. There was no greatest common factor, so that's my answer. All right, let's look at the next one. Check for the greatest common factor. There is not one in this, so we can skip that step. Make sure the degrees are greatest to least. 3, 2, 1, 0. Those are fine. Now we make the middle term positive. So I'm going to take this and make it plus negative 9. Now, technically, that's the same thing, but by writing that, it signals to your brain you have to pull out a negative factor. I'll show you what I mean when I get there. So step 4, two binomials. Step 5, take out the greatest common factor. So for the first one, I can take out y squared. And for the second one, this is where that's important. It's saying take out a negative. Make sure you take me out and don't forget me. So I'm going to divide by negative 3. Negative 9 divided by negative 3 is positive 3. And 3 divided by negative 3 is negative 1. Now these match. That's why the negative is important. Because if those don't match, we can't do factor by grouping. So our last step is to rewrite what we pulled out. Y squared minus 3 was one of them. And then 3y minus 1 was the other. All right, let's look at another one. There is no greatest common factor. There's no exponents, so they're in order. The middle is positive already, so we can start. Group. Take out our greatest common factor. Same thing on the other one. They both have an a, so I can divide out the a. Then I rewrite. 3 plus a is one of them, and x plus y is the other. All right, let's try another one here. There is no greatest common factor. They're already in order, 3, 2, 1, 0. We do need to make the middle positive. Now I do my parentheses, my greatest common factor. So I'm left with z plus 4. Take out negative 5, so I'm left with z plus 4. Rewrite. Z squared minus 5, z plus 4. As I go through these, I'm not explaining the steps as much because I've done a bunch. If you need me to go through these slower, just send me an email and we can either schedule a time or I can make another video. So here are these last 3. If you are comfortable, try them if you haven't yet. If not, watch a couple more, but make sure you at least try one of these to see how you think you're doing. Okay, first one, take out the greatest common factor. They are all divisible by 3. So 6 divided by 3 is 2. 12 divided by 3 is 4. 3 divided by 3 is 1. 6 divided by 3 is 2. Check our degrees are in order from least to greatest. 3, 2, 1, 0. That's all set. Make the middle positive. Group our two binomials. Take out the greatest common factor. So 2x squared, I'd be left with x minus 2. Take out negative 1, I'd be left with x minus 2. And rewrite. So we have 2x minus 1, x minus 2. Don't forget to bring down your greatest common factor that you started with. All right, let's try another one. These are all divisible by 2 and x squared. So we're going to take out 2x squared. 2 divided by 2 is 1. X to the 5th divided by x squared is x cubed. Negative 8 divided by 2 is 4. X to the 4th divided by x squared is x squared. 6 divided by 2 is 3. X squared divided by, or x cubed divided by x squared is x. Negative 24 divided by 2 is negative 12. And x squared divided by x squared is 1. Our exponents go 3, 2, 1, 0, so we're all set. The middle is a positive, so that's all set. Make my two binomials. Take out the greatest common factor. So here I can take out x squared. Here I can take out 3. Now I rewrite those. So we have an x squared plus 3. We have an x minus 4. Bring down our greatest common factor. We have factored this out. Last one. Greatest common factor. 2, 15, 3, 10. There is not one. Put them in order least to greatest. So we need the 3 first, then the 2, then the 1, then the no x. So now I have it in order from least to greatest. Sometimes it'll work without doing that, but this just makes your life easier if you always do the same thing. Turn the middle positive. Break into the two binomials. Take out the greatest common factor. Rewrite them. And that is factor by grouping, which is also the end of 6-1. Again, let me know if you have any questions.